Arc fault protection was incorporated into the National Electrical Code in the 2005 cycle, which went into effect in 2008. It is required for specific circuits in residential, commercial, and industrial buildings. In the 2005 National Electrical Code, it was required for all 15 amp and 20 amp branch circuits supplying outlets in dwellings. The 2008 National Electrical Code expanded the requirements to include non-dwelling units and additional circuits. Further revisions and clarifications were made in the 2017 National Electrical Code. Arc fault protection devices are designed to detect and interrupt dangerous electrical arcs that can lead to fires. They can distinguish between normal operating conditions and hazardous arcs, such as those caused by damaged wires, loose connections, or faulty wiring. Arc fault protection devices have experienced some issues in the past, including nuisance tripping and false positives. There is no general waiver in place for the use of arc fault protection devices. However, there may be specific exemptions or exceptions in certain circumstances, such as circuits essential for the operation of life safety systems, circuits supplying equipment that is sensitive to arc fault protection device nuisance tripping, and installations where arc fault protection devices cannot be installed due to physical constraints. If a situation is encountered where it is believed that an exemption may be applicable, consultation with a local electrical inspector or a qualified electrician is recommended. They can provide guidance based on the specific circumstances and applicable codes. An arc fault is an unintentional electrical discharge between two or more conductors. This discharge can generate heat and ignite nearby materials, leading to a fire. Arc fault circuit interrupters, or FCIs, are designed to detect these dangerous arc faults and quickly shut off the power to the circuit, preventing a fire from starting. There are two main types of FCIs: branch/feeder FCIs and outlet circuit FCIs. Branch/feeder FCIs are installed in the electrical panel and protect the entire branch circuit. Outlet circuit FCIs are installed at the first outlet in the circuit and protect the wiring downstream from that outlet. FCIs work by monitoring the electrical current flowing through the circuit. They look for specific patterns that are characteristic of arc faults, such as erratic current fluctuations or high-frequency noise on the line. When an FCI detects an arc fault, it trips the circuit breaker, cutting off the power to the circuit and stopping the arc. Arc faults can occur for a variety of reasons, including damaged or degraded wiring, loose connections, and insulation breakdown. These conditions can be caused by age, wear and tear, physical damage, or improper installation. It's important to note that FCIs are not a replacement for ground fault circuit interrupters, or GFCIs. GFCIs protect against electrical shock by detecting ground faults, which occur when current leaks to ground. FCIs protect against fires by detecting arc faults. The National Electrical Code requires FCIs in many areas of the home, particularly in bedrooms, living rooms, dining rooms, and other areas where arc faults are more likely to occur. This requirement has been phased in over time, starting with the 2002 edition of the National Electrical Code. The specific requirements vary depending on the edition of the National Electrical Code that is in effect in a particular jurisdiction. FCIs have been proven to be effective in preventing fires. Studies have shown that FCIs can reduce the risk of electrical fires by as much as 50%. However, FCIs are not foolproof. They can sometimes trip due to nuisance tripping, which occurs when the FCI trips for a reason other than an arc fault. Nuisance tripping can be caused by a variety of factors, such as electrical noise on the line or certain types of appliances. In some cases, nuisance tripping can be resolved by replacing the FCI with a different model or by making changes to the wiring of the circuit. Electrical codes and standards, such as the National Electrical Code, play a vital role in ensuring electrical safety in buildings. These codes are developed and updated regularly to reflect the latest knowledge and best practices in electrical safety. Compliance with these codes is essential for protecting people and property from electrical hazards. When installing or working with electrical systems, it is crucial to follow all applicable codes and standards. This includes using approved materials and equipment, following proper wiring methods, and ensuring that all connections are tight and secure. If you are not qualified to perform electrical work, it is best to hire a licensed electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to avoid electrical shock or fire. In addition to RFCIs and GFCIs, there are other types of electrical safety devices that can help protect against electrical hazards. These include surge protectors, which protect against voltage spikes, and tamper-resistant receptacles, which prevent children from inserting objects into electrical outlets. Electrical safety is an important concern for everyone. By taking simple precautions and following applicable codes and standards, you can help protect yourself and your family from electrical hazards. Furthermore, proper grounding and bonding of electrical systems are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Bonding connects all metal parts of the electrical system together, which helps to equalize the voltage and reduce the risk of electrical shock. Regular inspection and maintenance of electrical systems are also important. This includes checking for loose connections, damaged wiring, and other potential hazards. If you notice any problems with your electrical system, it is important to have them repaired by a qualified electrician as soon as possible. Over time, electrical systems can degrade due to age, wear and tear, and environmental factors. This can lead to increased risk of electrical hazards. By performing regular inspection and maintenance, you can identify and correct potential problems before they become serious. In addition to the technical aspects of electrical safety, it is also important to educate people about electrical hazards. This includes teaching children about the dangers of electricity and how to avoid electrical shock. It also includes educating adults about the importance of electrical safety and how to identify potential hazards. Electrical safety is a shared responsibility. By working together, we can create a safer environment for everyone. The National Electrical Code, or National Electrical Code, is a set of standards developed by the National Fire Protection Association, or National Fire Protection Association, to ensure the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Compliance with the National Electrical Code is essential for protecting people and property from electrical hazards. The National Electrical Code covers a wide range of topics related to electrical safety, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. The National Electrical Code is adopted by many states and local jurisdictions in the United States. In these jurisdictions, compliance with the National Electrical Code is mandatory. Even in jurisdictions where the National Electrical Code is not mandatory, it is often used as a guide for best practices in electrical safety. The National Electrical Code is a complex and comprehensive document. It is important to consult the National Electrical Code when installing or working with electrical systems. If you are not qualified to interpret the National Electrical Code, it is best to hire a licensed electrician. In addition to the National Electrical Code, there are other standards and regulations that may apply to electrical installations. These include standards developed by organizations such as Underwriters Laboratories, or Underwriters Laboratories, and the Institute of Electrical and Electronics Engineers, or Institute of Electrical and Electronics Engineers. It is important to be aware of all applicable standards and regulations when installing or working with electrical systems. Electrical safety is a constantly evolving field. New technologies and practices are constantly being developed to improve electrical safety. It is important to stay up to date on the latest advancements in electrical safety. There are many resources available to help you stay informed about electrical safety. These include publications from the National Fire Protection Association, Underwriters Laboratories, and the Institute of Electrical and Electronics Engineers. You can also attend conferences and training courses on electrical safety. By staying informed about electrical safety, you can help protect yourself and your family from electrical hazards. Firstly, understand that The arc fault circuit interrupters are designed to mitigate fire risk, particularly from arc faults that might otherwise go undetected by standard circuit breakers. Secondly, consider that the National Electrical Code mandates the use of arc fault circuit interrupters in specific locations, primarily in residential settings, to enhance safety. Thirdly, recognize that arc fault circuit interrupters technology has evolved, with improvements made to reduce nuisance tripping while maintaining their protective function. Now, delving further into the specifics of arc fault circuit interrupters, it's essential to grasp their fundamental principle of operation. These devices are engineered to discern between normal electrical arcs, which occur during the operation of certain appliances, and dangerous arc faults, which can ignite surrounding materials and initiate fires. This distinction is crucial for minimizing unnecessary disruptions while ensuring prompt intervention when hazardous conditions arise. The sensitivity of arc fault circuit interrupters is calibrated to detect a spectrum of arc fault signatures encompassing both high current and low current arcs. High current arcs are typically associated with short circuits or ground faults, while low current arcs may stem from damaged wiring or loose connections. By vigilantly monitoring the electrical circuit for these telltale signs, arc fault circuit interrupters can swiftly de-energize the affected circuit, thereby averting potential fire hazards. Moreover, arc fault circuit interrupters incorporate sophisticated algorithms to differentiate between legitimate arc faults and benign electrical phenomena. This capability is paramount for mitigating nuisance tripping, which can undermine confidence in the device and lead to its circumvention. Factors such as motor starting, fluorescent lighting, and electronic equipment can generate electrical noise that mimics arc fault signatures, potentially triggering false alarms. Through advanced signal processing techniques, arc fault circuit interrupters can filter out these spurious signals, ensuring reliable operation in diverse electrical environments. In addition to their arc fault detection capabilities, arc fault circuit interrupters also provide overcurrent protection akin to traditional circuit breakers. This dual functionality safeguards against both arc faults and overloads, offering comprehensive protection for electrical circuits. Furthermore, arc fault circuit interrupters are rigorously tested and certified by independent testing laboratories to ensure compliance with stringent safety standards. These certifications validate the device's performance characteristics and adherence to established safety protocols, instilling confidence in its reliability and effectiveness. However, despite their numerous advantages, arc fault circuit interrupters are not without limitations. Nuisance tripping remains a concern in certain installations, particularly in older buildings with aging wiring or erratic electrical loads. While technological advancements have mitigated this issue to some extent, it's essential to address any underlying electrical problems that may contribute to nuisance tripping. Proper wiring practices, such as ensuring tight connections and avoiding sharp bends in conductors, can help minimize the likelihood of arc faults and nuisance tripping. Moreover, selecting arc fault circuit interrupters that are compatible with the specific electrical loads in the circuit can further reduce the risk of false alarms. When troubleshooting arc fault circuit interrupters, it's important to follow a systematic approach to identify the root cause of the problem. Start by visually inspecting the wiring and connections for any signs of damage or loose connections. Then, use a multimeter to check for voltage drops or ground faults that may be contributing to the issue. If the problem persists, consult with a qualified electrician to perform a more thorough inspection and diagnosis. In some cases, it may be necessary to replace the arc fault circuit interrupters with a different model or brand to resolve nuisance tripping issues. Additionally, consider upgrading the wiring or electrical panel to improve the overall reliability of the electrical system. Arc fault circuit interrupters are an integral component of modern electrical safety practices, providing enhanced protection against fire hazards. By understanding their principles of operation, limitations, and troubleshooting techniques, you can ensure their effective implementation in residential, commercial, and industrial settings. The technology behind arc fault protection is quite sophisticated. It's not simply about detecting a surge in current like a standard circuit breaker. Instead, arc fault circuit interrupters, or FSIs, are designed to analyze the waveform of the electrical current. They look for irregular patterns and high-frequency noise that are characteristic of arc faults. Imagine the electrical current flowing through a wire like water through a pipe. In a normal, healthy circuit, the water flows smoothly and consistently. But when an arc fault occurs, it's like the water suddenly sputtering and splashing, creating disturbances in the flow. The arc fault circuit interrupter is able to detect these disturbances and quickly shut off the power to prevent a fire. There are different types of size, each designed for specific applications. Branch/feeder size are installed in the electrical panel and protect the entire branch circuit from the panel to the last outlet. Outlet circuit of size, on the other hand, are installed at the first outlet on the circuit and protect the wiring downstream from that outlet. Combination of size offer both branch/feeder and outlet circuit protection in a single device. When choosing an SI, it's important to select the right type for the application. The National Electrical Code specifies where SIs are required in residential buildings, and it's crucial to follow these requirements to ensure safety. One of the challenges with SIs is nuisance tripping. This occurs when the SI trips for a reason other than an arc fault, such as electrical noise from appliances or other equipment. Nuisance tripping can be frustrating and inconvenient, but it's important not to disable or bypass the SI. Instead, try to identify the cause of the nuisance tripping and correct it. Sometimes, the problem can be resolved by replacing the SI with a different model or by improving the wiring in the circuit. If you're experiencing frequent nuisance tripping, it's best to consult with a qualified electrician to troubleshoot the problem. They can help you identify the cause of the tripping and recommend the appropriate solution. Installing SIs is a relatively straightforward process, but it's important to follow the manufacturer's instructions carefully. If you're not comfortable working with electricity, it's best to hire a licensed electrician to install the SIs for you. They have the knowledge and experience to ensure that the SIs are installed correctly and safely. Maintaining SIs is also important. Periodically test the SIs by pressing the test button on the device. This will simulate an arc fault and verify that the SI is functioning properly. If the SI doesn't trip when you press the test button, it may be defective and need to be replaced. Electrical safety is a critical aspect of home ownership. By understanding the basics of arc fault protection and following the National Electrical Code requirements, you can help protect yourself and your family from electrical fires. Remember, SIs are not a replacement for other safety measures, such as regular electrical inspections and proper wiring practices. They are just one component of a comprehensive electrical safety plan. Always prioritize safety when working with electricity and consult with a qualified electrician if you have any questions or concerns. The integration of arc fault protection into the National Electrical Code reflects a growing awareness of the dangers of arc faults. These faults can occur in a variety of situations, such as damaged wiring, loose connections, and overloaded circuits. Arc faults can generate intense heat, which can ignite nearby materials and start a fire. The goal of arc fault protection is to detect these dangerous arc faults and quickly shut off the power to prevent a fire from starting. SIs are designed to be more sensitive to arc faults than traditional circuit breakers. They can detect arc faults that are too small to trip a standard circuit breaker, but still large enough to pose a fire hazard. This increased sensitivity is what makes SIs so effective at preventing electrical fires. While SIs have proven to be effective in reducing the risk of electrical fires, it's important to remember that they are not a foolproof solution. SIs can sometimes fail to trip in the event of an arc fault, and they can also be subject to nuisance tripping. For this reason, it's important to maintain SIs properly and to follow other electrical safety practices. One of the ongoing challenges with SIs is the development of more advanced technology that can reduce nuisance tripping without compromising safety. Manufacturers are constantly working to improve the performance and reliability of SIs, and new models are regularly introduced to the market. As technology continues to evolve, we can expect to see even more effective and reliable arc fault protection in the future. Ultimately, the goal of arc fault protection is to create a safer electrical environment for everyone. By understanding the technology and following the National Electrical Code requirements, we can help reduce the risk of electrical fires and protect lives and property. Another important aspect to consider is the impact of arc fault protection on electrical system design. When designing an electrical system, it's important to take into account the requirements for a size and to select the appropriate devices for the application. This may involve choosing different types of a size for different circuits or using special wiring methods to minimize the risk of arc faults. In some cases, it may also be necessary to install additional surge protection to protect sensitive electronic equipment from damage caused by voltage spikes. Proper electrical system design is essential for ensuring safety and reliability. By following the National Electrical Code requirements and working with a qualified electrician, you can create an electrical system that is both safe and efficient. In addition to the technical aspects of arc fault protection, it's also important to consider the human factor. Electrical safety is everyone's responsibility, and it's important to educate people about the dangers of electricity and how to prevent electrical fires. This includes teaching children about the hazards of playing with electrical outlets and appliances, and reminding adults to follow safe wiring practices and to maintain their electrical systems properly. By promoting a culture of electrical safety, we can help reduce the number of electrical fires and protect lives and property. Arc fault circuit interrupters are an essential safety device in modern electrical systems. They offer enhanced protection against electrical fires by detecting and interrupting dangerous arc faults. While they have limitations, ongoing technological advancements continue to improve their performance and reliability. By understanding the technology following the National Electrical Code requirements and promoting a culture of electrical safety, we can create a safer electrical environment for everyone. Remember to consult with a qualified electrician for any electrical work or if you have any questions or concerns about your electrical system. Prioritizing safety is paramount when dealing with electricity.